Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week, and it centers around taking a look at the seasonal hurricane forecast, hurricane season forecasts that come out of Colorado State University. Dr. William Gray pioneered this effort beginning in 1984, and it continues today, even though Dr. Gray is no longer here. But Philip Klotzbach, who was a graduate student with Dr. Gray way back in the day, has now become a seasoned professional, and he continues to carry this effort forward. And there definitely is some skill. It's not exact, but it certainly is better than having no clue whatsoever as to what the next season is going to be like. But there is a caveat to all of this, I think, and I'll get to that at the very end. All right, so let's go on ahead and get started here. And we're going to take a look at tropical cyclone climatology, and the period that is used is 1991 to 2020, which is the exact same period of time that is used for quote-unquote normal high and normal low temperatures, or the 30-year average. So for named storms, it's 14.4, hurricanes 7.2, major hurricanes, which is category 3 or higher, at 3.2, and ACE 122.6. I'll talk about ACE in just a minute. Now, if you take a look at the average plus or minus 1 standard deviation, which would basically be about 66 to 67% of all of the storms, okay? So sort of the middle of the bell curve. That actually is a pretty good range, all the way from 9 to 20, hurricanes 4 to 10, major hurricanes 1 to 5, and ACE 59 to 187. All right, so what the heck is this ACE thing? Well, it turns out that kinetic energy, okay, if you remember back to your science days, is equal to 1/2 times the mass times the velocity squared, okay? So the velocity squared is the key term here. And so ACE stands for accumulated cyclone energy. So what you do is you take the maximum sustained wind reported in the 6 hourly advisories and you square those numbers, okay? However many 6-hour advisories there are, you take the maximum sustained winds for all of those, I believe in knots, pretty sure, and then you square those values and you add all of them up, and then you divide by 10,000. Why do you divide by 10,000? Because if you didn't, you squared some pretty big numbers, you're going to end up with a unmanageable number. So this sort of brings it back into a usable range. So here's an example. Let's suppose that we're taking a look at a 24-hour period with the tropical cyclone, and the maximum sustained winds are 45 knots, then they go up to 55, then up to 75, then up to 95. So if you square those 4 numbers, you get 20-25, 30-25, 56-25, and 90-25. You add all those up, you divide by 10,000, and for that 24-hour period, the accumulated cyclone energy for that storm would be 1.97. Now, most storms last more than 24 hours, and a lot of storms have winds that are a lot higher than that example. So you can see how that 1.97 is pretty low. All right, so let's take a look at all 4 categories here. From the period 1991 to 2020, the number of named storms verification. And you can see I've split this up into 2 halves, 1991 to 2005. There's the forecast, there's the observed, and there is the difference, okay? So a couple of years stand out. 1995, there were 19 named storms, but only 10 were forecast. And in 2005, there were 28 named storms, and only 13 were forecast. Now, the folks at Colorado State do an April forecast, a June forecast, and an August forecast, okay? What I did was I took the earliest one because I wanted to see how the forecast verified before the season actually started, okay? Because what happens sometimes, especially in August, is that you've already had a number of storms, and so you can sort of see how things are unfolding and make a forecast based on that. But I wanted to see, you know, how do they do before the season ever gets started, okay? So out of those 15, only 2 were what I would say not all that terribly good. And then if we take a look at the years 2006 to 2020, it was over forecast by 7 storms in 2006, under forecast by 9 in 2012, under forecast by 6 in 2017, and under forecast by 14 in 2020. Notice that most of these differences are minus. So this whole idea that some people have put forth that the Hurricane Center is exaggerating and over forecasting and all that, the numbers don't bear that out at all. And you'll see that here. Now the average error averages out all the absolute values. In other words, if you were under forecast by 7, and then the next storm you over forecast by 7, then the average error would be 0. They cancel each other out. When you take a look at I'm sorry, I said that wrong. If you average those two, plus 7 and minus 7, then the bias would turn out to be 0, okay? But if you take the absolute value of those two numbers, which are 7 and 7, then the average error would be 7, okay? Does that make sense? I hope so. All right, so let's move on ahead here to the number of hurricanes. And again, the first 15 years, there's only one that I would call close to an atrocity, and that was 2005, when it was under forecast, again, by 8 hurricanes. And then in 2006 to 2020, we had an under forecast by 6 in 2012, a over forecast of 7 in 2013, a under forecast in 2017, and an under forecast in 2020. So again, 3 out of those 4 were under forecast. The average error, okay, which is the absolute value of all those numbers, is 2.9. The average bias, minus 0.7. So again, more times than not, it is under forecast. Now, here's the number of major hurricanes, category 3 or higher. And you can see that there was an under forecast of 5 in 1995, over forecast of 4 in 1997, an under forecast of 4 in 98, and a under forecast of 8 in 2005. And we move on ahead to the next 15-year period, an over forecast of 4 in 06, under forecast of 4 in 2010, under forecast of 6 in 2012, 7 over in 2013, 2017, under forecast by 6, and in 2020, under forecast by 6. So in this case, the average error 1.6 and the average bias minus 0.5. Now, the reason that accumulated cyclone energy is used is that you can have a number of short-lived storms, because we're better now at detecting activity in the Atlantic than we've ever been, mainly because of satellites. But if you have a whole bunch of short-lived storms, it piles up that number of storms, but they're insignificant in terms of the overall amount of energy for the hurricane season. So let's see how things turned out with regard to ACE, okay? 1991 to 2005, you can see the differences over to the far right. And one year, again, that stands out, 1995, when the ACE was only forecast to be 92 and it was 227. So that's a pretty big error there. In 1998, under forecast by 94, and in 2004, under forecast by 97. Again, all 3 of those are under forecast. And in 2005, minus 110. So 4 for 4. And then from 2006 to 2020, the ones that stand out the most were 2013, which was an over forecast, and a 2017, which was a huge under forecast. Okay? So the average error was 54.7, and the average bias minus 12.9. All of the average biases in all 4 of these categories were all in the minuses. And then you have the one up there at the top, the 2 at the top there. Okay, so final point. There have been 4 Category 5 hurricanes that have struck the United States, at least that we know of. And the first one was the Labor Day hurricane of 1935 that hit the Florida Keys. Storms were not being named back then, so they just called it the Labor Day hurricane. Then Camille in 1969, Andrew in 1992, and Michael in 2018. So the number of hurricanes, the average, the 30-year average today is 7.2. So in 1935, there were 5 hurricanes, so that was below normal. In 69, with Camille, it was well above normal at 12. 1992 with Andrew, below normal. And 2018, we're splitting hairs here. Yes, slightly above, but 0.8, I would call that pretty much a normal hurricane season. So in only one of these 4 cases was the hurricane season well above normal, and yet these are the 4 worst storms, 4 most intense storms that have ever hit the United States. So my point here is that the number of storms doesn't really matter. It only matters how strong each storm gets, and more importantly, where it goes. If you go to anybody that lived in Homestead, Florida in 1992 when Andrew came through and you tell them it was a below normal hurricane season, you might not get out of that discussion alive. Homestead was annihilated by Andrew, okay? Absolutely flattened. It took years for that area to come back, and people that live in Florida tell me that there's still evidence down there of what happened with Andrew, and that was, what, 33 years ago, okay? So it only takes one. You can have a whole bunch of hurricanes out there in the middle of the Atlantic that never make landfall, and all they're doing is giving fish panic attacks, but there's no impact on humans in the United States. Or you can have one hurricane, it's a bad one, hits a populated area, and the impact is huge. So I always told people, prepare every year exactly the same way. Assume there's going to be one hurricane, it's going to be bad, and it's headed straight for you. If it doesn't happen, don't be mad, be thankful. Same philosophy with tornado warnings, okay? Chance of it happening is relatively small, but if it does and you're not prepared, you're in big trouble, okay? So that's my recommendation. I think this is interesting research to be able to look at the overall atmosphere and tell differences from one season to the next, like is it going to be more active, less active. I'm sure for shipping and anything that involves spending a lot of time over an ocean, that this is very, very helpful information. I just think in terms of human impact, the media in general makes way too much of it, okay? It's like if it's an above normal season, oh my gosh, we're all gonna die, okay? And if it's a below normal season, it's like ho hum. Well, what if one of those below normal storms turns out to be a Cat 5 and it hits you, okay? So those things are not emphasized to the degree I think they should be, at least in my humble opinion. All right, that is it for now. That's bonus weather video number 1 for this week. Number 2 will be coming up Wednesday. Number 3, Friday. Next daily weather update coming up on Tuesday. So hope you join me for all those. In the meantime, happy Tuesday, because that's when I'm recording this now. And we'll talk to you soon. See you later.